Okay, we're halfway through the course, so today's the hump, and we're in the second thing, so you should be able to finish everything for assignment 1 now, and assignment 2, like if I uploaded some things already, but I'll open the portal at a later stage, and just to avoid that you submitted the wrong portals, for example. But you can already find some of the information for assignment 2 online, and what you have to do there. So last week we talked about moderation effects, we talked about ANOVA designs, and so basically interactions. And today we talked about two-way ANOVAs, 2x2 ANOVAs, 2x4 ANOVAs, 2x5 ANOVAs, and basically examining those interaction effects and the post-hoc tests and all that. And today we'll talk about mediation. So moderation and mediation are not the same. And this is the other side of the coin, and this is also something you might have heard about already, but it's quite common in psychology to do mediation designs. And that's why you'll learn about them today. So the goals today is that I'll show you some diagrams and how to make some diagrams, and so you don't have to always resort to PowerPoint perhaps to make some pretty diagrams. And then we talk a little about mediation. Again, as perhaps with some other techniques, there are many, many ways to do this, and many ways to reach the same goals. Also, when I showed you ANOVA, there are many ways of achieving this, and I'll show you some of the common ways to do this and how they map onto what SPSS does, because your supervisor might ask you to do something similar to SPSS, and I'll tell you the most common methods of how to do this. And the nice thing is that, for example, on these computers, you would have to install special SPSS syntax, or otherwise it wouldn't work. And it's quite buggy, so it sort of depends on whether it works, and you might not be able to install on all of them. And so that's also, if you have to do lots of mediations, again, it's just a matter of amending your codes and running them over and over again, rather than having to press the button like 25 times. So after today, you should be able to complete the following parts of your assignment. You should be able to do the bit on mediation, the Baron-Kenny steps approach. You should be able to do a Sobel Z-test. I should also be able to do the Preacher and Hayes method, which is the bootstrapping method, or the thing which people do with the SPSS plugin. And then I'll talk to you a little bit about the Emite, Kiel, and Tingley method, which is a more novel method of doing mediation. And you should also be able to do that by the end of today. Have any of you ever conducted a mediation test? Have you ever used this type of macro in SPSS? Do any of you know what a mediation is to begin with? No? Have any of you come across an article perhaps in Journal Club where people tested a mediation? Or it's always been moderation or main effects designs? Nobody came across a mediation? So mediations are basically when we talk about causal chains where we have A predicts B, B predicts C, and we assume that B is the mechanism explaining the path between A and C. And so that's quite interesting to test, especially if you're a social psychologist or a clinical psychologist, and you think, for example, it's something in the mind which does it, then you would propose a mechanism in the middle which explains away the variation, the path between A and C. Does that make sense? So if you can draw, you can't really plot it as like charts, because basically you would have charts in sequence. So usually you have these arrow diagrams. So you have a path going from A to B, and then from B to C, and then you want to see if the path via A, B, C, if that reduces the relationship between A and C, if it explains it away, basically. That's the premise of mediation. Yeah? So everybody sort of understands the concept? So basically, the goal here is usually that you want to test a mechanism or some type of causal path in a chain, and that explains away the relationship between two variables. Yeah, perhaps you can think of a scenario where you would. Is there anybody of you who thinks that they might use this type of causal chain in their research or in their currently in their internship, like how it would work, or any type of idea of how you would do that? No. You all have main effects in moderation designs. Yeah, pretty much. Well, perhaps Dane, for our thing, so one scenario would be that we try to prime somebody's hunger, so we try to elicit hunger, Then we have a psychological measure, which measures people's hunger states. And then we have an outcome measure, which is people's preferences for larger objects. So that would be a causal chain where our experimental manipulation influences people's hunger states. It has a psychological effect, which we predict is the mechanism, which in turn affects people's perception of bodies or perceptions of clocks or perceptions of something else. So in that case, we would test the mediation design if we think that that psychological mechanism exists. So for example, people's ratings of hunger, that would be in the middle. And we're hoping that that explains the path between our manipulation, which would be people skipping a meal or making them think about when they're really hungry, and the outcome measure. Yeah? Does that sound sensible in terms of what type of designs you would be able to test? So usually this is interesting psychology because you have a hypothesis about the psychological mechanism or something, or a scale somewhere in the middle, and you try to explain that pathway by that example. And I'll come with some other examples later on. So have a think, perhaps some of your research questions can be recast in these causal diagrams, and they're quite neat to test it that way. So it's grown out of path models, and basically, as I explained, you have a path A to C, and then we are interested in the intermittent link in B, and so we might be especially interested in the relation between A and C is fully explained by B. So basically, suppose that this is a really significant relationship, but after we add B to the mix, that this is no longer significant, then B really might explain away all the variations. So in that scenario, it would mean that the hunger manipulation is completely explained by people's psychology or their psychological functioning as to how they then perceive the bodies. Yeah. And so that might be an interesting scenario to test, and that's why people have historically been interested in testing this. So if we go all the way back, basically what it is all about is this chain of regression analysis. So it's basically nothing more than orderly squares regression, which you've done, but now a sequence of them, one behind the other. So you can think of them every single time as a sequence of regression analyses chained together. And so, and what we can then simply do is we can divide the contribution of the coefficients, for example, by multiplying them. We can see how much they contribute to explaining the outcome variable, and that's how that's basically the premise of how it works. So note that we won't do that today, but ideally, you know, orderly squares regression comes with a whole host of assumptions, which we've tested in the lecture. So today I won't go through all those assumption checks and all those tests again, but you should be aware that if your data is really bimodal, for example, if it's not normally distributed, you wouldn't be able to use this type of method. Same if some other problems arise, you wouldn't be able to use this path analysis or this mediation analysis because the assumptions of OLS regression need to apply. Yeah, and that means for every single step along the chain. But for today, for pragmatic purposes and also in your assignment, you won't be asked to test all those intermittent steps. But you should be aware that if you go out and do full-blown research, you should be able to every single time think critically about whether your assumptions are met for regression. To be honest, many different researchers don't do that. They just do the mediation analysis and don't bother with looking at the assumptions, but you should be able by now to look at the regression assumptions. So it also means that there are no loops allowed. So you can't have a path diagram where suddenly an arrow goes back to something in the middle, or you have so you can't have any loops. So arrows can only point one way, and they can't point back in a different direction, because then we're unable to partition the paths, and we're unable to say which one contributes to the other one. So that's why there shouldn't be any loops. There are more complex ways of dealing with loops, but for mediation analysis, in principle, there are no loops. Any questions thus far? So it is there are more advanced ways of doing this, and it comes from network theory, and it has to do with how, because networks are nothing more than basically nodes connected via directed arrows. There's a whole mathematics of network theory and directed acyclic graphs, which also allows you to do all sorts of testing about causality, but I won't cover any of that today. So there's more advanced ways still to do all this, which you should be aware of. But for now, you should just know that orderly squares regression, it's it's basically tracing the paths, and there's no loops around allowed in this method. Any questions? Does this ring a bell? Did any of you have any mediation analysis whatsoever? You only talked about moderation in your, but you did talk about regression, right? In your undergraduate degree. So don't be too frightened. It's nothing more than basically a sequence of regressions, what we're doing now, in a more fancy way. So people have referred to this as causal, and I've also used causal mechanisms because the idea is that you can sort of identify the contribution of that thing of the B path in the middle. So what do you think? Is it really causal or not? Any ideas? Can we derive causality or not? There's no wrong answer. So I know it's quite intimidating in a group session to say this, but we can just discuss. Don't make me point to people. Okay, what do you think? Would it be causal or would it not be? No, you, yeah. Because you just took a big sip of water, so.
Yeah.
You would say it's causal. Yeah. And how would we be able to derive causality?
So many things.
You have no idea. So I think if you think back, unless we experimentally manipulate variables, it can't be really causal. So unless you experimentally manipulate the B path in the middle, we don't really know causal because it is all correlation in the end, right? So unless we experimentally manipulate all the steps in between, then we can, so if we randomly assign people to the B path, to path A or path B, then we would be able to make strong inferences in terms of causality. But if we don't do that, it's all just correlation, because regression, as you remember, is also correlation. Yeah, so you can reduce regression to correlation coefficients. So it is all correlation, and so often you can put. So suppose that we didn't do manipulation in the beginning, but we just have different scales. We could play around with the order of those scales. So we say that, for example, time orientation influences people's hunger perception, and that influences people's perception of judgments. But we could have flipped those around anyway, because that's just a theoretical-based choice, and unless we experimentally manipulate time orientation or that psychology of hunger scale, we don't really know what's going on. So often the choice of arrows is arbitrary, unless you have full experimental control or temporal order. So people do something first at time A, and then at time B, and then at time C, then it's clear that something from, especially if they're distinct manipulations, it's clear that something from the past can influence the future, but something from the future should be able to influence the past. Yeah, unless we have chaos theory and infinite loops and all these other things. So there's a temporal order. So if you have experimental manipulations, then things become clear. And some people take a hard line and say you can only ever use this type of models that I'm teaching you today when you have experimentally manipulated the path in the middle, because then only then can you infer causality. And so it's very easy to slip into causal language, and I'll also do that throughout here, but you should always bear in mind that what we're dealing with is correlation. So we're drawing the arrows, and sometimes quite arbitrarily, and we could have put something else as the mediator or the things, unless there's a really good theoretical reason, for example, or we experimentally manipulated it, and we know, or there's a temporal order. We know that C happened at the end and A happened at the beginning. Yeah. Does everybody understand what the issue is? So the other issue is that there's hidden confounders. There might be things which we might not have measured. Again, think of the example where we just have two scales. There might be something which we didn't measure which influences the scores in two scales, and that is explaining all the paths away. And so basically where we say, aha, this is the causal mechanism, it's a third variable which is influencing both the independent variable and the mediator, explaining away the path. I'll put up some charts to make it clearer in a bit. So unless you experimentally manipulate these things, there's always room for hidden confounders. So if you randomly assign people at the mediator step, then you're hoping that would break any type of causality or break any type of effect of this hidden confounder. But if you don't do that, there could be something lurking in the background explaining both the independent variable and the mediator. Yeah. So now something more basic. So perhaps I wanted to show you an alternative how to draw diagrams in R as opposed to PowerPoints. So PowerPoint can do all sorts of nifty manipulations. And so there's a package called Diagrammer, and that will allow you to draw some diagrams which you might need also for some things. So it's this, and a mermaid is a type of chart which is sort of a sequence chart. And what we then have is LR for left to right, and then it's just a series of strings. So you have to basically draw every single time the arrow and then name the variable you want to have in the chart. And so that's so every single time, and I'll show you what it gives you this. And so it has just the first letter and then the label we would like to have in the diagram. So you have to draw out a chart for yourself and see how all the arrows are going, and then we can actually get it to draw a chart for us. So unfortunately, it went wrong in the handout, and I'll try and correct that. So I might have printed a small thing, and that's because it's an HTML widget, and that doesn't play nice always with embedding in other formats. But this is sort of what you would then get to get at. So if we go back, we have a path from age going to fertility, so that's that big arrow to the end. And so you can draw quite complex charts relatively easily by using your code. So especially if you for your thesis, if you have to draw lots of charts or lots of things, this might be easier than spending time in tinkering in PowerPoint, trying to get the arrows straight and trying to do everything. It will give you fairly clean charts to do it. Yeah. So in this case, so this is a more complex. So this is not a single mediation model, but this is a complex proposed causal relationship between age and then fertility as a function of all sorts of other variables. And it's just an example. Don't focus on the context, just to show you how to draw these charts. We can make it even more beautiful, and that's by changing some of the labels and some of the digraph. And again, I won't have time for every single package to show you everything it can do, but just to show you that this package exists, and then you should play around with it and see if you can get some nice charts going yourself. And so here we define the nodes. So the nodes are basically the circles, and the edges are the arrows between the circles. And so it's just, it wants to update. Sorry about that. So, and it tells you the direction here from left to right, and tells us we want black arrows, we want like a nice V-shaped arrow, and you can basically change any type of aspect you want from that chart if you wanted to, and then you can get something nicer looking, perhaps like that. There's no more boxes, and you have something that looks like this, where the arrows are curved. So you can get really nice, pretty charts without having to tinker necessarily in PowerPoint to draw all these arrows, or to tinker in Adobe Illustrator or some other things. So I'm not sure if you ever had to draw diagrams and how you did it. Might have done it in word art or objects and like that. But this will hopefully make your life easier in terms of drawing charts. Yeah, drawing diagrams. So I've just shown you some examples, but you can use it for all sorts of charts. You can get Gantt charts, which are these you can get sequence charts. So just look at the diagrammer package if you need to have diagrams drawn, which might be the case if you do this type of causal chain designs. So that's a really quick intermezzo as to how to make charts, and now I'll go back to the mediation bit. So as I've said, you should be aware that there's differing views. Some people say mediation is only ever useful if you can manipulate the thing in the middle, and other people take a more lenient view and say basically you can test mediation or test any theoretical model, even if it's all correlational. You can go out and test that with the mediation model, because you can test their theory, you can plot the arrows, and then test it that way. But some people take a hardline view, and I'm not sure how your supervisors will differ in terms of views, but some will say we can only ever test mediation if we manipulate the thing in the middle by an experiment or by a study. Yeah. And so again, be aware of the sequencing. So if you propose something, then ideally it should be measured after IV. So the temporal order of the chart, also the chart we saw from left to right. So age can't be at the end, because so fertility can't influence age. So you should think about the logical temporal sequence that exists in those orders. And if you can't, if it means, for example, that in your experiment things were measured in not consistent in the order of your diagram, that's going to be a problem, yeah, in terms of making a claim that this is the causal pathway, because you should have thought about the design and you should have then ideally measured it in sequence as it is mapped onto the thing, unless you think that it's all measured so closely together and there's like a psychological construct which carries it all the way through that it doesn't matter. But most of the time you should really care about the temporal sequence in which all these things are measured. Any questions so far? Tell me if I'm going too fast or things are unclear. So we'll use a data set which is similar to data sets from that, and I'll work through these things, and then we have an in-class exercise where you can toy around with yourself. And so I just called it D first because it's a very long link and already overflows the box rather than data mets, and then I just assigned D to data mets to give it a more recognizable name. Yeah, so by now you should know you can use the arrow to assign objects, and you can rename objects also via assigning by the arrow. So it has three, it's just very simple. It has grades, happiness, and the proposed mediator is self-esteem in the similar to dataset. So basically, people have grades, that influences their self-esteem, and that in turn influences their happiness. And the idea would be that the self-esteem explains away the relationship between grades and happiness. Does that make sense? So a toy example, not real data, but just to show you how it works. So basically, it's arguing that there should be, so the classic approach is that there's three steps to it. And so this is Barron and Kenny's method, which you come across, or you can read that paper. And that's the classical approach to in order to demonstrate mediation. So there's three steps to demonstrate the existence of mediation. So X should be related to Y. So in our example, grade should be related to happiness. Yeah, if grades are not related to happiness, then perhaps there's nothing going on. X should be related to M, so the mediator should be related to the independent variable. So grade should relate to self-esteem. And there should be a relationship between X plus M and self-esteem. And actually that relationship should then drop that original one out of significance. So basically, after we control for the mediator, the effect of X is no longer there. That's basically the premise. So after we control for self-esteem, this relationship between X and Y is substantially diminished, and that would point to the fact that it's explained away by self-esteem. Yeah? Everybody with me so far? So that's the three-steps approach. Actually, there's a fourth step, and that's just to complete the figure. So sometimes you also want to regress just self-esteem on happiness, so that you also can draw that arrow, because I'll show you in a bit that you can have all the numbers on the thing. But in order to test the mediation, that's not necessary. You can read more there. And as an aside, that paper has 71,000 citations in Score Google, so it's really one of the most common methods which people have used to test this. So if you've shown all those three steps, then you conclude there's mediation present in your data. And all those steps are nothing more than a series of regressions. Yeah. Just to put a graph to it. So what I was talking about, what wasn't listed as step 4, is this path, but you also might want to add a number on that when you make a nice figure. So you basically would then put regression coefficients on all of them. And for this one, you put the regression coefficient for the direct relationship, and then when you control for the mediator. And you're hoping that there's a big difference between those two, because that means it's explained away via M. Yeah. And basically, this multiplied by this is our test if there's a mediation going on, because that would then explain the difference between those two coefficients. Yeah? Everybody with me? So this is, in our example, just thinking, keep on thinking that this is happiness, this is grades, and this is self-esteem, and that's the model we're trying to test. So there's not a single scatter plot you can do, for example, because it's a sequence of regression, so it would be multiple scatter plots. So usually when it's also recorded, it's these type of diagrams which you'll see with coefficients attached to it, rather than seeing a plot with dots or something like that, because it's a series of regression, so we need like a three-dimensional space of something to in order to plot. Any questions or clear so far? So step one, there should be a significant relationship between x and y. So in our case, there should be a relationship between grades and happiness, and we're hoping that in a simulated data that magically will work. So that's what we find. So again, by now we should be able to do a regression. So I just labeled it model 1, and then it's y times x, because that's what the data is called. Data met, which is the data from which we get it, and then we just ask for a summary. It will printed things below here, but we're mostly interested here in whether this coefficient is significant or not. Yeah, so that's the significant step, and you can see it's highly significant. So note that these are b's and not betas. So again, you were aware that there's differences between standardized coefficient and unstandardized coefficients. If you want to standardize coefficients, you would scale everything as we've done in the regression practical, and then you would get to standardize, you would get the betas out of it. Everybody knows the difference between betas and b's, yeah? So one is the unstandardized shift, and the one is a standardized coefficient, and betas usually range between 0 and 1. Sometimes they can go higher than 1, but don't worry too much about that. Yeah, so we found evidence for our first step. So that's that arrow if we go back. So that we satisfy that step. Now there's some controversy. Some people have claimed and actually shown that you don't have to have that first step significant for there to still be mediation. So according to Barry and Kenny, if that first step is not significant, so if you find nothing, you should stop, and that's it. There is no mediation. There's no point in going further and testing it along. And that's that was their initial view. But according to other scholars, you could still move forward even if there's nothing going on there. So even if that's not significant, you can still move forward and go and test the mediation. That's because you could have suppression going on, and then as long as there is a strong theoretical rationale for a relationship between x and y, then you can move ahead. It would take a lot of explaining, but basically the idea would be that there's such a strong relationship that it would entirely have explained away that direct pathway, that you would have mediation still, but without having that first step significant. Yeah. But if you follow Baron Kenny, if there's nothing happening at step 1, you stop there, and that's the end of it. And you can I've attached a paper to it, and you can read more about the different views on that. So basically, the reason why those cases are saying is it's because there's suppression happening, and the mediator is suppressing the relationship between x and y. So that was the first step. The second step is that there should be a relationship between our independent variable and the mediator. So in this case, there should be a relationship between grades and self-esteem. And if that's not happening, then there can be no mediation because we need that path for it to work causally, or at least for M to be doing something and explaining away that relationship between x and y. Yeah? Again, it's nothing more than a regression, but now we do a different regression. We do the mediator is the dependent variable, x is the independent variable, this is the data, and again the summary of the model. And unsurprisingly, in the simulated data, it's highly significant. So here we also find support for step 2. Yeah. So far so good. Step 1, check. Step 2, check. Now we move on to step 3. So the effect of x should be reduced when we include the mediator. So that's basically sort of pointing to these two arrows. And so the b for x should be substantially reduced in size or drop out of significance. But beware, because the difference between significance and insignificance is not significant in itself. So if you go from, let's say, 0.05 to 0.07, that's not significant in terms of shift. But based on our cutoffs, that would seem significant. Yeah. So, but we're hoping that this relationship sort of drops out of significance when we include the mediator in our model. Yeah. So basically, again, it's a regression, but now y is again our dependent variable, and now we've added the mediator just in this way. Call it a data frame, call it model 3, and what we see here is that the mediator is significant, But our coefficient for x, which was highly significant in step 1, has dropped out of significance and is now 0.71, and that's quite a big shift. Yeah? And we can also compare that. So this one was 0.0396 in terms of B, and if we go back to step 1, it was 0.3961. So it's actually tenfold the size originally, and then when we add the mediator to control, it's only a fraction of that. Yeah, it's shifted by a factor of 10. Yeah. So that's the third step. So the coefficient dropped from 0.39 to 0.04. That's rounding. It also dropped out of significance. But is this significant in itself? And we'll return to that later when we compare models in structural equation models. So what we can do is we can test, is the model with just one arrow, is that a better model than a model with 3 arrows? And we can use fit indices to compare that. But we can also then test, now what we'll do is we'll test whether that pathway is significant, whether that A times B path is significant. Okay? So how would you report it? Typically, people just do it graphically and make this type of diagram, and this is just an example. And you should have seen those already in your in some of the articles you've read, and so on. And so people add the B or beta coefficients, depending on whether you use unstandardized or standardized ones, and then they use the star notation for significance. So now we're going to try and do it yourself. You can download the datasets from that link, either by going there, or you can, if you right-click and save as, you should be able to directly download these SPSS datasets. I would like you to conduct a causal steps mediation analysis with math as the independent variable, read as the mediator, and science as the outcome variable. Yeah. So basically, it's a series of regressions which you've done. So right-click and download the dataset. You'll need the Haven package to read the SPSS data, and then do step 1, step 2, step 3, and it's just a sequence of those